Cancer, a cellular plague since the dawn of humanity. Film 3, Targeting and Fighting. Our immune system is a highly complex biological system. Every day, it produces billions of new cells devoted to defending our body against invaders, bacteria, or viruses. It has its own production sites, foremost among them in the thymus and spleen, with hundreds more in the lymph nodes, its own distribution channels, the lymphatic vessels, and an entire arsenal of weapons to deal with every possible threat. So why can't our immune system simply destroy the cancer cells that are so intent on destroying us? What is the body's police up to? Thanks to advances in the field of cancer immunology, we now understand how cancer cells manage to avoid detection. In the 1990s, immunology researchers James Allison and Tasuku Honjo began to take an interest in T cells, the body's police force. These keepers of law and order have receptors on their surface that allow them to recognize healthy cells. When T-cell receptors come into contact with healthy cells, they sign a kind of non-aggression pact. But cancer cells are masters of deception, producing receptors of their own that they use to deceive the T-cells at the points of contact. This gave the researchers the idea of using trained antibodies to block these checkpoints. Once the cancer cell had been unmasked, the immune response could finally be activated against it. But that was just the beginning. The antibodies produced by our immune system had plenty more surprises in store. These tiny proteins also had the ability to target cancer cells and interfere with their replication mechanisms. This is the idea at the heart of the research conducted in the TACT project. Today, chemotherapy remains the most commonly administered treatment for cancer. Its cytotoxic power is ruthlessly effective against cancer cells. The problem is that chemotherapy also affects healthy cells. But what if the antibodies themselves could be used to deliver chemotherapy drugs directly to the cancer cells, and only them? A form of chemotherapy that would directly target affected cells while leaving healthy ones untouched. This is what we call an antibody-drug conjugate. But there's more. Some antibodies are able to bind to cancer cells and T-cells, bringing the two together. Once the introductions have been made, the T-cells can get to work. We call these antibodies bispecific antibodies. For 4 years, the 11 PhD students at TACT have been pursuing various avenues of research. Some have been thinking about the best way to attach cytotoxic drugs to antibodies to make sure their cargo is delivered only to cancer cells. Others have been encapsulating chemotherapy drugs in nanoparticles to make it easier for them to penetrate cancer cells with no risk of them being released into the body. Still others have been figuring out which substances are best suited to fighting particular types of cancer. Their research and discoveries, like those of all their predecessors and contemporaries, bring new contributions to the field every day. Having started from zero more than 5,000 years ago, thanks to the gradual accumulation of data, new generations of treatments, and targeted therapies, we now have an ever-growing arsenal at our disposal. Our hope is that one day, the most destructive cellular plague humanity has ever faced will be consigned to the history books once and for all.